Okay, so in this video, we are going to wrap up our shortcuts on proving triangles congruent. Again, keep in mind this chapter, that's kind of been the key focus. So far the ways that we can prove triangles congruent was in the first lesson, we proved all three sides and all three angles congruent. In the next lesson, we learned about side angle side congruence. The next two that we learned together were side, side, side. And specifically in right triangles, you can use hypotenuse leg. And then the last two that we have here, the last two shortcuts, are angle, side, angle, and angle, angle, side. None of the other patterns will work. So again, now that we have all these patterns and we're going to go through a couple theorems and proofs, basically it's our job to distinguish whether we have one of the patterns or not, and if that's enough information to prove our triangles congruent. So the learning goal of this lesson will be to just use and prove those two congruence theorems. And again, most of it is just recognition. As far as the proofs and theorems go, a lot of the setup is the same. So another construction bonus opportunity. Again, guys, we have a lot of time in class to do this. It's pretty simple. You need a compass and a straight edge. They're at the back of the room. Take the opportunity when they're there for you to boost your grade a little bit for these. So the first one we're going to learn for today's lesson is angle, side, angle. So it says if two angles and the included side of one of the triangles is congruent to two angles and the included side of a second, then the two triangles are congruent. So again, you can see here in the image, we have angle congruent to angle, side congruent to side, and angle congruent to angle. Now that we have that information, the rest of those things can be proved congruent using corresponding parts of congruent triangles. So you'll start to see that acronym once we prove triangles congruent. Again, keep in mind this acronym will start to pop up. So in other words, when I'm doing a proof, if I prove these two triangles congruent using angle, side, angle, the next line you might see in a proof is something like angle B is congruent to angle E. Well, now that we know the triangles are congruent, we can say that by corresponding parts of congruent triangles. So keep that in mind, those will be coming. The other one, again, this works for all triangles. It says if two angles, if two angles in the non-included side of one triangle are congruent to two angles in the non-included side of another, then they are congruent. So again, you can see the difference in the pattern, whereas angle, side, angle, the side that was congruent was in between. Angle, angle, side works as well. So keep in mind, guys, now what this gives us is basically if we know two angles are congruent in a triangle, we know that those triangles are congruent because there's really no way around it. So if I have any given triangle and I know two angles are congruent, let's just say it's these right here. Regardless of what side is congruent, if I know a side is congruent in this figure, I know that I can prove them congruent. I just need to know the difference between if the side is in between, that's angle, side, angle. And if the side were on either one of the sides, I'll just mark the right side. That would be angle, angle, side. But those triangles will be congruent. So if you know two angles and any side, we know for sure those triangles are congruent. So in these images, and again, they're never going to tell you vertical angles or the reflexive property in an image. They're not going to mark that. So we need to know enough about those two properties to realize that's what's going on. So in example one here, if I focus in on these two triangles, they want to know if they can be proven congruent. So if I look at these two triangles, I have an angle in the top and I have the side opposite that angle. So what I'm looking for is what are the patterns that have a side and an angle. So my options are side, angle, side. I have angle, side, angle. And I have angle, angle, side. Now, we don't know these are right triangles, so I can't really use hypotenuse, leg, and I obviously don't have side, side, side. So now what we need to do is eliminate our options. So for side, angle, side, I would need the sides on either side of my angle to be congruent. So I know that that one's not it. For angle, side, angle, I would need an angle, the side included, and then an angle. So I can clearly see this is not my side that's marked congruent. So that's not what we want either. But if I look at this one here, if I wanted to, I could do angle, angle, side, and we can tell that these two are congruent always. They don't need to be marked because they are vertical. So the reason those two triangles are congruent is by angle, angle, side. Okay, the next image here, we have all three angles marked congruent. And again, we don't have any sides that we can say for sure. If we had any other information, because we have two of those angles congruent, if we had any other information, we could prove them congruent. But because we have three angles, those cannot for sure be said as congruent, even though they appear to be. This one here, again, you'll notice we have two angles marked congruent. So we have our options are angle, angle, side, angle. And again, we don't have two sides marked, so I won't even mess with that. So two of the angles are marked congruent. You can see here that the shared side in the middle is part of both triangles. So the pattern is angle, side, angle. So again, part of what we do going forward will just be kind of recognizing whether or not we have congruent triangles. Once we think that they are, we have to kind of distinguish which pattern we're using. So can you prove that these two triangles are congruent? So it says here that all these lines are parallel, opposite one another. What we need to know is, do we have enough information to prove those two triangles congruent? What I would say is, because I have parallel lines, I know that 1 and 3 are congruent by alternate interior. I also know, because those outside lines are parallel, that 2 and 4 are congruent. So this literally looks just like this image right here, and it has to be the same thing. We are using angle, side, angle. So yes, those can be proved congruent using angle, side, angle. Okay. Everyone's favorite. So we have a proof here, and it says right up top that we're using angle, side, angle. So take a moment, pause, copy this into your notes, try this proof out, see if you can't fill in some of these blanks. Now that you've had an opportunity, let's start with the given. So for the given statement, we have AD is parallel to EC, and we also have BD is congruent to BC. And those things are marked in our image for us already. So the parallel lines are going to help us out, and then you can see right away we're using them in the next line with alternate interior angles. So the angles that are inside these parallel lines, if I want to use angle, side, angle, these are interior, but these are interior as well. So what I want to do is I want to look at how I want to prove these congruent. So technically we could prove these congruent using either, and that would be 100% correct. But we're setting ourselves up for angle, side, angle. So we can see here down below in our proof that ABD and EBC are congruent. That's these angles right here. So it looks like if we're using angle, side, angle, we want to use angle, side, angle. So I can go back in my proof and say these are the alternate interior angles that I want. So I can say angle D is congruent to angle C by alternate interior angles. The next line says BD is congruent to BC. We know that because that's what we were given along with those parallel lines. So I noticed that I put that up there as well. We can cross that out. Okay, it's below in our proof. That's a simple fix. We can cross that out. And then lastly, I marked it in my image, but I have ABD and EBC are congruent. These, again, are not going to be marked congruent, but those are always congruent when they are opposite each other like that, because those are vertical angles. And we learned vertical angles were congruent way back in chapter 2. So now lastly, I can say that triangle ABD is congruent to triangle EBC, and that is by angle side angle. So again, we have another monitoring progress here. So go ahead and try and prove in the diagram. Take a moment, pause, try these. Like I said, it doesn't hurt to have these practice runs because we still need work on them. So go ahead and take a shot. All right, with perpendicular lines, arguably we could have an extra line kind of in the middle. And so I kind of am going to guide you on those sometimes. You'll notice that I will take a couple different answers there. But what we have at our first statement line is a given. We have that AB is perpendicular to AD, and DE is also perpendicular to AD. Our next line says AC is congruent to DC. That is also, if you'll look up there, a given statement. Now, what we have here is we have a bunch of right angles created because these lines are perpendicular to AC. Now, I need them to be congruent, and I can just say angle A is congruent to angle D, and I can say that by definition of right angles or by definition of perpendicular lines. They're going to create right angles, and we know all right angles are congruent. So because I did that in one line, I would take either one of those. We know that all of them are congruent regardless. Lastly, I have ACB and DCE are congruent. Once again, pretty common theme popping up a lot this chapter. We have that because of vertical angles. And so now finally, I have a side, or excuse me, I have, my side and an angle and an angle. So if I look at my pattern, I can say that triangle ABC is congruent to triangle DEC, and that's by angle, side. Okay, next, again, pause, try it. I'm going to go through it kind of quick here. So we have a given for the first reason, GHF, and is congruent to HGK. Again, I was given perpendicular lines. I'll mark where GHF is, so that's right here. And then HGK is right here. Those will be alternate interior angles. Okay, we have those are right angles congruence theorem saying that all right angles are 90 degrees and that they are congruent. And lastly, we have HG is congruent to GH simply by the reflexive property. And then now we can say, again, if you'll notice and look at your pattern, we have angle, side. So we have angle, side. Okay, so once again, we'll go through this kind of quick. We have our statement, S and U are congruent by given. We also know that our S is congruent to VU by given. So if you'll look at our pattern and what we have, it looks like we either need to prove these are congruent, which we can't because we don't know for sure they're parallel. So what we can say for sure are that these vertical angles are once again congruent. So I can say angle RTS is congruent to angle VT or UTV. We'll go UTV to keep corresponding parts matched up, and that's by vertical angles, which we've used on literally almost every proof. So now I can say triangle RST is congruent to triangle VUT, and that's by angle, side. So again, a summary is right here. You can see all the patterns. Again, we can only use hypotenuse leg in right triangles, but always what will work is if you prove all 6 sides, which would be kind of silly at this point because we have all these nice shortcuts. Note the images and their differences and what they look like. That's kind of a big thing for this chapter, is just simply being able to identify the differences between them. So In summary, hopefully we can recognize and use improves angle, angle side, and angle side angle. Again, your homework's posted. Be sure you ask questions. Make sure that you understand for the lesson going forward and get that skill check done after your practice set. Thanks and have a good day.